Thanks everyone for joining me in this session about mobile JavaScript and performance. And I'm really excited to be here in Forward.js because I believe that JavaScript is shaping and will continue to shape the future. And in that future, there are no kind of network of websites. It's a network of things or a network of applications, so to speak. It's kind of contradictory to what Christian Heilmann said in the keynote, but it's going that way. So that's why mobile is so important in that future. And you, as everyone in this room, is a part of that future, and it's kind of really exciting to be in that kind of transitional area or in that kind of transitional era. But let's rewind back from the future and go to the present time. So picture this. You're in a line just trying to buy some snacks and your movie is just about to start soon. What will you do next? Chances are that you'll pick up your phone and start playing Flappy Bird or poke someone on Facebook or I don't know, do a check in on Foursquare, which has been swarmed right now, so it's ridiculous, but anyway. Or do any bunch of other things that doesn't take too much time or too much attention. The thing is, there's some kind of hidden anxiety in this situation because you don't know when the cashier will call you next. So this kind of lack of time and lack of attention is really exactly the reason why mobile development or creating a fast, intuitive, simplistic, and responsive mobile application is really of premium. And in this talk, I'll try to emphasize on why creating or developing for mobile environment is harder than it seems, what are the typical challenges and limitations of mobile, and what we can do to overcome them. But before that, let me briefly introduce myself. My name is Volkan, and I'm a mobile engineer at Jive Software. And Jive is a platform that does social business collaboration, so to speak. Or you can think of Jive as something that makes Monday mornings suck less. So my website is in here. My GitHub handle is this one. You replace O with a 0 because there was a namesake that is not me. And you can find all the slides and source code of this presentation in my personal website, so you don't have to take screenshots or copy down everything. But feel free to do so. There is no, disclaimer or something, basically. And having said that, in this talk, in a nutshell, we'll try to figure out whether it's really possible to create a really fast and intuitive and snappy JavaScript application in a mobile context, given that we are limited by every possible constraint imaginable in a runtime environment that is not so friendly to us. So JavaScript is kind of a different beast. And when you dive into it, be it on the server side or on the client side, it's all the debugging and closures and callback hells and memory leaks and all the stuff. And being in a limited container as in mobile just amplifies that kind of pains in the rear, basically. And we'll try to see and figure out how to solve those kind of issues. But before starting the session, I'd like to emphasize that whatever you hear is totally dependent on the context. So don't take anything for granted. Just know that the important thing is not the tips and tricks that I share in here. It's the process. It's how you approach a problem, how you solve it. Things might have been totally different in your situation, and the only way to know that what's working for you or not is to actually test it, measure it, and benchmark it given your particular setup or scenario. Having said that, let's dive into the challenges and limitations of mobile as a platform. Mobile has several constraints. One of them is the network communication. The other is the lack of battery or the power usage. The other is the memory, and the other is the processing power. When it comes to network communication, network is really expensive in mobile in terms of lags and delays and connectivity issues. And also battery consumption is a major issue because everybody knows if you have an iDevice, the battery dies in a day. That's what kind of sucks. And you have to be really cautious about what kills your battery, and you have to take special precautions against them. And also memory is not as much as a desktop browser. So in a typical mobile device, you have, if you're lucky, you have a gig of RAM. in an Android device, you have half a gigabyte of RAM that's shared with all the applications that are active on the device. So it's not too much. And the other thing is processing. Mobile processors are not designed to do fast computations. Instead, they are designed to dissipate as little heat as possible, and also they are designed to consume as less current as possible, which makes them slower than their desktop counterparts, basically. So we have those kind of limitations. We'll dive into each of them as the time goes on. So, but one important thing is the battery, because all of those constraints are kind of tied to battery consumption as well. The more network you use, the more you consume your battery. The more complicated your JavaScript is, the faster your battery dies. And no matter how pretty your application is, or no matter how useful your application, or how simplistic your application is, if it sucks the battery like a sponge, then the first thing that the user does will be uninstalling the application. And the second thing that the user does will be swearing at you publicly on Twitter. And I have seen that. So in not my company, but I have seen people just shouting at other companies in Twitter because they are draining battery too fast, basically. And there are a bunch of factors that kill your battery. One of them is the network requests, because your phone is nothing but a shiny dandy radio antenna or radio basically, and the radio communication takes a lot of power. So the more network requests you do, the more AJAX calls you make, the more kind of power states change in your mobile application, the faster your battery will drain. So a way to overcome this will be to either cache stuff or batch stuff and send, instead of sending 5 requests, sending a batch request and receiving the response in a batch way. And the other thing that consumes your battery is JavaScript, because JavaScript is processing, and the more JavaScript you have, the faster your battery will be drained. And there are a bunch of issues to it. One of them is the complexity of the JavaScript. So the more kind of object-oriented your structure is, or the more objects you have around, or the more interaction in it. So if you have a really complicated pop-up pattern that does some elegant architecture, chances are that it might be consuming your battery, and you might need to revisit that architecture in the context of mobile. If it were a desktop application, it might not be that kind of an issue, but in mobile, you have to learn to be frugal. And the other thing is images. As a rule of thumb, you should not display any images that are not inside the viewport. And secondly, you have to use as little images as possible. The ideal, in an ideal length, there should be no images. Everything is like boxed, and there's no shadows, no gradients. But we don't live in such a scenario. So you use your own judgments. The less images, the better, basically. And the last but not the least piece is DOM, because DOM is a really big monster to compute with or compete with. And as a rule of thumb, if you have more than 5,000 nodes in a page or in a viewport, or if you have more than 12 to 15 levels of DOM nesting, then your application's performance will gradually degrade. So you have to try to keep the number of DOM nodes constant on your application. When we consider all those constraints, we tend to see that mobile and desktop are, although kind of look similar, they are different. They serve for different purposes. Mobile is kind of more lightweight, more general purpose, and desktop, per contra, is more powerful, basically. But it doesn't mean that you cannot create a fast and intuitive application in mobile. Just you have to know your environment. If you can embrace the fact that mobile is something more general purpose, then you can really create a really nice and dandy and fast applications for it. And we have to be fast because, as we have seen before, our users want us to be fast. And sometimes they want us to be faster than the desktop application because the users have really limited time. If you are on a line waiting for, I don't know, some form to be processed and somebody is calling you next, you don't want to just click the button and load an application, or you don't want to wait too much. You have your gestures and your responses should be as simplistic and as quick as possible. because users have limited attention, limited time, and also limited precision. The finger is really fast; it's not a cursor. And when it comes to speed, there are a bunch of dimensions of the speed. One of them is the network layer, the overall network communication. The other is the performance in rendering, how fast you can render stuff. The other is the caching layer, and the other is reaction. By reaction, I mean how fast the user responds, how smooth the user gestures are. And the other is the overall JavaScript execution, how fast your loops are, how optimized your functions are. And there are literally books written for each and every single topic on this. And in this talk, I won't be diving into too much details of this. Instead, I'll try to give you some cursors or pointers so that you can, if you're interested, you can dive in deeper or read books about it or go to videos and watch the videos, because it's too much stuff to cover in 40 minutes time, basically. And so let's start with the funnest one, the network communication. Network in mobile is really expensive, and the expensiveness is not the bandwidth, it's the latency. Because we know that we try to create minimalistic applications in a mobile environment. Therefore, we don't consume the network a lot. It's basically a plain text JSON request or response, and we don't send too much data, and we don't receive too much data. But the thing is, each and every single HTTP request you make can come up with a latency of half a second or 1 second, and seeing 3 to 4 seconds of latency in mobile environments, depending on the device's radio communication state, is not uncommon. So you have to learn to live with latency. Latency is not a luxury, it's a given in mobile, and you have to work around that, as we'll see further. And to reduce the latency or to fight with latency, there are a bunch of approaches that we can take. Firstly, the fastest network request is no network request at all. So if you can put your assets like CSS, JavaScript, some images, I don't know, some files locally on the device and serve them locally, that's the fastest way. And if you cannot, you can utilize caching techniques. And also, when you do an AJAX request, use kind of a smart caching technique with which you don't have to do the request over and over again. If you have it in the cache, just serve the cached version. And the other thing is to decouple the user experience from network activities, and we'll see an example of this soon. So by decoupling, I mean you have to abstract your data access layer. So if you, in your mobile application code, if you see some kind of request like this is not the best way to do it. In this piece of code, we are simply doing a network request to a REST API endpoint. And it really seems innocent, but we can do it better. So instead of doing this kind of a simple request, we can try to abstract things. And abstraction is a double-edged sword. So if you abstract things too much, it will be harder to maintain, harder to read, and it will become slower in terms of performance. But certain parts of abstraction or certain parts of code, when abstracted, may be more beneficial to you. And let's see. So one of the places that you can abstract is the data access layer, because you will be doing a lot of caching logic and a lot of access manipulation and all the black magic in the data access layer. Therefore, being it abstracted away will decrease the impact of regressions and all the code problems, basically. And the other thing that we can abstract is the rendering layer, because once we abstract the render layer, then it will be much easier to spot out DOM-related performance problems. If the jQuery or the whatever DOM code, DOM filtering code you use is spread all over your code base, then it will be really hard to benchmark things. It will be hard to isolate things or write test cases for it. Writing a test case for a web view is a different topic of its own, and whether we should write it or not is also a separate topic of its own, but abstracting DOM at least helps it to isolate the issue a little better. And the other thing is latency. And as I said, it's not the bandwidth that's the problem, it's the latency in the mobile network. And mobile network requests are expensive, and I won't dive into too much detail because it's a real topic of its own, but you can keep in mind that the latency and all the sluggishness of the mobile network is due to the extreme complexity of the wireless mobile network architecture. And if you want to have in-depth information about this, you can visit this link and get Ilya Grigoryk's excellent book on the subject matter. It's free to read online, and if you want, you can purchase it and get a print copy if you like. And it's a perfect book. I suggest if you have time to read it and get a grasp of the overall background of things. So the bottom line is latency in mobile is high, and latency in mobile is highly variable. And therefore, to sort things out, you have to have an offline mode. As we have seen in the beginning of this event, offline is not a luxury anymore. You have to have an offline, and you have to plan for an offline access, because we are not always online. If you are in a conference room, you'll try to fiddle out entering those wireless access code, and then pray for the conference gods that the access code will work as it's supposed to be. But most of the time, conference network sucks. So offline is a part of mobile life, basically. And to have an offline mode, you have to have a caching strategy. Also you have to have a intelligent backup strategy. So you try a request. If it fails, you try it once more. If it fails again, you try it once more with increasing intervals, like in 2 seconds, in 4 seconds, in 8 seconds. And if the request still fails, you just give up. You don't try it over and over again, because trying the network connection over and over again also consumes with battery, and also it heats up the device. I don't know, I have experienced this myself, and probably you have too. There is poor network connectivity, and you see a loading spinner in the phone screen, or some kind of a network connecting indicator, and the phone is literally burning in your hand. That's the reason why the phone is trying to connect to the base tower, and it's not getting a good communication, and it's trying to retry the request over and over again. And the problem is, in that kind of a scenario, first the phone heats, and the heating of the phone means that the battery is draining, and it's kind of a double-wise problem. So the phone is heating, and your battery is draining like lightning, and it's two perfect reasons for your users to hate you and uninstall the application, and then curse you at Twitter, basically. And the other thing about performance or speed is the rendering layer. And when we think of rendering, CSS paint times is not free. And there are a bunch of CSS properties that we need to pay special attention to. And those are shadows and gradients and like big fonts or custom fonts, kind of. And when we combine one or two or more of these kind of things, it might become gradually slower. So especially if you are trying to do cool CSS animations or cool CSS effects on a big list of big infinite scrolling list, then you'll see that the performance of those scroll action is not as you expect. So the less CSS you have, the better, basically. And also, it's true for animations. You can, as a rule of thumb, think that on mobile the animations will be, if it's JavaScript written, the animations will be around 3 to 4 times slower than its desktop counterpart. So try to use as little animations as you can, and try to use CSS for animation, because it's GPU accelerated and it's optimized for just animating or moving stuff around. But this is not also a hard and cold fact that you can do. If a jQuery based animation works for you, then go ahead with it. But just test your assumptions, basically. But CSS is always faster than a script based animation, basically. And the other thing that we can optimize on the rendering layer is templates. And when it comes to templates, going logicless has a bunch of advantages. One of them is the template is generally at the bottom of your rendering hierarchy. So the more logic you put into the template, the more complex your overall flow will be. And probably you are repeating the template in a repeater structure to render a kind of either nested tree of things or list of items. And the more logic it has, the slower the overall flow will be. So the other advantage of the logicless templates is swappability, basically. So if you have some server-side templates and if you have some client-side templates, and then once in a while you decide to move the client-side template to the server or take some template from the server and render it on the client, you'll find out that a logicless approach, which will be much more versatile than trying to figure out which parameter goes where or how we can express the if block in that template language in a different way in the server-side template. And the other thing is try not to nest your templates, and by the same token, try not to nest your Vue objects. We'll see a bunch of examples regarding that soon. But before that, let's see our biggest enemy, basically. And our biggest enemy is DOM. And there are a bunch of reasons for it. One of them is the fact that DOM is a slow and synchronous API. And when you try to access a DOM element, or when you try to change the DOM, since JavaScript is single-threaded, then you're kind of tossed. Unless the DOM operation completes, your UI freezes entirely. Therefore, the less you touch the DOM, the better. And there are a bunch of ways that you touch the DOM that you don't know of. One of them is just reading an DOM attribute. Even if you read an attribute on DOM, like a offset top or offset left, or a border kind of dimension, box size, there will be a bunch of style recalculations that will trigger layout thrashing and which will make the things slower. So try not to read DOM, try not to write to DOM. So what else you can do? But the thing is, try to cache things as much as you can. So if you are reading some attribute from DOM, just put it in a place and then use the cached value instead of trying to read it over and over again. And if you are trying to write something to DOM, one way to do it is to detach all the nodes and do the manipulation offline and then reattach the nodes back into the DOM tree. And the other way is to kind of yield your operations with a set timeout so that it doesn't affect the overall flow of things. But the bottom line is the less you touch DOM, the faster your application will be. And there are ways to measure the effect of your DOM manipulation or CSS manipulation. And there are tools for that. So if you are using Chrome developer tools and if you enable the continuous repaint mode, then you can take you can play with the viewport, you can add some CSS rules, some DOM elements, change the HTML, and see what kind of layout combination is faster or renders faster or has a higher frame rate. And if you want something more granular, then you can use the high resolution timing API. And in this example, we are basically doing that too. So in this example, we are first getting an element and hiding the element and flashing all the style changes, then displaying the element and flashing again the style changes and taking 2 timestamp differences in between. And the difference between those timestamps is a rough estimate about how the overall rendering or overall rendering load or overall rastering load of that chunk of element is. And to make it reliable, as in every statistical thing, this kind of test should be repeated over and over again, and then the edges should be cut out, and then the entire result set should be averaged out. But at least this kind of approach gives you a more granular way of controlling things or measuring things. And aside from Chrome, Opera has a CSS profiler, and I'm sure Firefox has a similar profiler too, but I have not tested the other profilers myself. And the other thing that we were discussing is not to nest Vue objects, and we are seeing an anti-pattern that does it in this example. So here, we are appending a child node to a document fragment by calling a render method of a Vue object, basically. And the only purpose of this Vue object is just to create an HTML chunk and append to a DOM fragment. And then this kind of newly created Vue object is discarded for garbage collection. And this is too much of a burden for our precious garbage collector. And especially if this is kind of representing an infinitely scrolling list or a really fast changing part of DOM, then the garbage collection will be kind of shooting ourselves in the foot. And we can kind of create a simplistic approach, and instead of using a full-blown view object that we will be discarding and not using at all, we can use a simpler template-based solution. So we can use a precompiled template and then put our whatever data structure we have to just create a HTML to it. This is kind of better because first we are using less objects, and the less amount of objects we use, the less force on the garbage collector that we'll have. And the second thing is, since the template function is precompiled, it will be kind of faster. And we can do better though. So instead of using a template function, if we know the difference of what parts of the page change, we can get the delta of the changes, like this section of the page changed and this section of the page hasn't changed. And then for each change in our change set, we can just pinpoint and modify that part of the DOM. This is kind of implementing a virtual DOM approach that React.js and other libraries are doing. But my point is not that. My point is the more optimization you do, the more complicated or the more complex your code gets. And therefore, you have to know which parts of the code base to optimize, because optimization comes with a maintenance cost with itself. Therefore, if you are in a whirlpool of optimizing, and you come to this kind of a conclusion that you have to take a delta and loop all the nodes and kind of come up with a faster solution, just benchmark and think whether it's worth it or not. Maybe it's worth it, maybe it's not, but it totally depends on your application, and you cannot know whether it's a productive approach or not if you're not measuring it. The other thing is jank busting, and I don't have too much time to dive into this as well. And I strongly suggest you to go to jankfree.org and watch all the videos and all the tutorials there, because it's a hell lot of information there to consume, and they are really quality resources. I can say that you have two goals to hit in terms of creating a jank-free application. One of them is to create a 16 milliseconds per frame kind of animation, and the other is to have a consistent frame rate. To maintain a frame rate consistency, you can utilize the request animation frame API. And it's not an easy task, but it's not the hardest thing at all. So it's not rocket surgery, basically. But it takes some time to practice. But it's an important thing, especially in mobile, because the mobile users are less patient than the desktop users, basically. And the other layer that we can optimize is the caching layer. And we have seen that we have a problem about the unreliability of network. Latency is a killer in mobile, and network requests are expensive in terms of response times. And the solution is to batch your requests and then cache your responses and utilize offline modes and all that jazz. But when we try to come up with a caching solution, we open another can of worms, such as where to cache. There are a bunch of places that you can cache, and one of them is the HTML5 application cache, which sucks. Therefore, it's hard to deal with it. IndexedDB has issues with it. WebSQL is not supported anymore. And in those kind of a scenario, when I bump into this kind of a scenario, my thought would be to go with the dumbest solution that have in hand that works. So because if it works and it's dumb, then it's not dumb, basically. And local storage tends to be the simplest solution. It's a simple API, it's standardized, it's well-behaved, it's really fast, it's just like a key value store. And some people complain about the, I/O rate of the local storage, or say that the local storage requests are causing a blocking I/O and that might be slower, which, to my observation, is not the case, because it's not the I/O. It's not the I/O that's the bottleneck most of the time. It's the rendering, it's the DOM, it's the parsing, it's the layout trashing. It's much higher or much different things that you need to focus on. And when we decide to use local storage, then we open a different problem box, which is what caching policy that we should use. One problem is the size limit of local storage. although 5 megabytes might seem like a lot, you'll soon see that it will be eaten up in a practical real-life application. So as a solution, you can partially store the data or minify your JSON responses, which is a good thing, both in terms of network and in terms of the object footprint on your JavaScript application. And also, you can compress the data, like using a zip-like compression algorithm. But when you compress the data, there is also a decompression overhead. So again, you have to test and verify and validate your assumptions in that. From time to time, I have seen that compression works great. And particularly if you are targeting kind of more recent mobile devices like Android greater than Jelly Bean or iOS greater than iPhone 4, then compression works fine. But if you are kind of targeting low-end devices like Ice Cream Sandwich and below, or iPhone 3GS, and there still are users that use iPhone 3GS on the planet, then compression might be an overburden in that case. So it totally depends on your scenario, your user base, your market, basically. And we have seen that abstracting stuff is useful in certain cases. One of them was abstracting the rendering layer. The other was abstracting the network communication layer. And it is also true for caching. Try to abstract your cache layer and try to have a single cache entry point. This will make it much easier to detect cache-related problems. And the one other thing is to cap the size of each of your cache entries, because you would not like a 3 megabyte blog post or the JSON response of a 3 megabyte blog post to consume up all your cache and don't leave anything behind. And when we have cache, a cache eviction policy is also required. And most of the time, last recently used algorithm is the best way to go. But depending on your application structure, you might want to do different cache eviction or cache usage algorithms. And when you try to implement that kind of an algorithm, you have to know the size of your cache. And since JavaScript doesn't have a one-to-one correspondence of creating a size of a object, the only way to use is to use the JSON.stringify of the local storage. And this is not a big kind of a burden because JSON stringify is a native operation and it tends to run quite fast. I haven't tried to benchmark and test it to the limits of it, but for all practical production code, I didn't have any issues while I take the length of an item by stringifying it. And the next thing is the reaction, which is the overall user responsiveness. If you can keep one thing in mind about the reactiveness, you should be considering not to block the UI, basically. So if the UI if the user is in motion, if the user is doing a gesture like panning, swiping, zooming, pinching in, pinching out, so does the UI respond accordingly. And there are two key metrics in here to accompany with that. One of them is the 16 milliseconds per frame, as we have seen before, and the other is 100 milliseconds per user action. These are the psychological limits that the users intuitively feel that the application is slower if they pass that kind of threshold. So if you tap on a button and the button doesn't respond to you for half a second, then it's kind of poor user feedback. Similarly, if you swipe something and the UI doesn't respond, and once your gesture ends, the UI changes its state, then it's also poor user feedback. When the UI is in motion, when the user's hand is in motion, basically, the UI also should respond to the user accordingly. And there are ways to accomplish it, as we'll see a bunch of examples soon. This is also kind of an anti-pattern. So in this function, we are handling an AJAX response. So what's wrong with that? The thing is, an AJAX callback has a feature of blocking a bunch of things. One of them is the request animation frame loop, and the other is the main UI thread. And it depends from browser architecture to browser architecture, but generally, if the user is doing some kind of a gesture and an AJAX callback comes in, then the screen freezes for a while. And you can see this kind of interaction or lack of interaction in, again, infinite scrolling list. While you come to the end of the list, you try to do another scroll. The application fetches the data and tries to put the data to the bottom of the list while the user is trying to scroll it. And the UI can freeze for a couple of seconds in that scenario because it's trying to do too much. As a rule of thumb, you can, if you can, try not to do any JavaScript action while the user is doing some kind of a gesture, because there are a lot of things going on, like rasterization, or things being uploaded to the GPU and things being stashed away and rendered back in. So the browser is doing too much, and adding a bunch of additional burden on top of it is kind of counterproductive. And to solve this kind of issue, we can do a simple modification. So we can hold a flag that checks whether the UI is in motion or not. And if the UI is not in motion, then we can handle the AJAX response. So this kind of is useful because if we are sure that the user is not doing any kind of gesture, it doesn't matter whether the content loads in a second or in half a second, because most probably the user is passively interacting with the UI. She's either looking at an image, or she's reading kind of a title or an article. She's just consuming the content, and it's a perfect time to gather an additional set of content and try to prepare for it. So this is kind of a solution for that. This is not perfect. There will be edge cases, but this kind of at least gives the concept of it. And when it comes to UI and CSS and all this stuff, the next thing that comes to mind is event handling. And when it comes to thinking about event handling, the first thing that comes to mind is to utilize event delegation. Event delegation is a pattern that has been coined, I don't know, 6 or 7 years ago, or maybe before that, that insists on using or binding the events to the container of a set of items instead of binding to each and every single list item in a kind of list. And this has a bunch of uses or a bunch of advantages. One of them is you create a lesser amount of functions, so there is less code to deal with, and hence there is less chances of regression or bugs. And the second thing is it uses less memory, so it is friendlier on the memory side. Most of the time, event delegation patterns are faster. There are some exceptions to it when we compare certain kind of tap events on certain kind of items, but these are kind of edge cases. And also, event delegation kind of helps, I don't know, it's generally useful. And the other thing that I see while attaching and detaching events in different kinds of codes is a pattern that you try to attach something, and then after an action, you detach those kind of events. And the most common thing that I see is during a swipe event, you attach a bunch of handlers, and when you do a tap leave action, you detach those handlers. But if we kind of follow a delegation philosophy, then leaving those handlers intact would be much better, especially if you try to reduce the number of event handlers and not to attach and detach events too much. You'll really see that the overall application performs better, especially in lower grade devices. You might not see too much of an advantage in a newer Android phone, but you can see it really shines in older Androids or older iOS devices. And the other thing about events are some of the events kind of fire too frequently, like mouse events or device motion events or kind of scroll events. And in those kind of scenarios, the best practice is to decouple the UI interaction with the event state data. So in this particular example, we are trying to move a DOM node every time we get a device motion event. And this is kind of a killer in terms of memory, in terms of performance, in terms of CPU utilization, and in terms of battery. So instead, we can kind of decouple these event state from the event action by using a request animation frame loop. So this is kind of a simplistic solution to that. So in the device motion event, we add an event listener and put all the device all the information that we are interested in a state bag. And then we fire and request animation frame loop. And when we are sure that we can process those kind of event information, we just move the object to the place that we want to. This can be enhanced, so this is kind of a simplistic example just to show the concept, but the overall logic is to decouple your event state from the event application to the DOM, which also is in parallel with the motto that touch the DOM as little as you can. So, and the ideal place to touch the DOM is generally when the animation frame fired or the animation frame ticks at certain times, because at that time the browser is sure that it can render an additional frame, and it will be less damaging than trying to render it at abrupt timestamps, basically. This was delegating the frequently firing events, and those kind of events, as I said, are device motion, scroll, anything that you feel like is firing like crazy is a target to this kind of optimization, but it doesn't mean that you cannot do it in every single event that you have. It's just a trade-off that you have to decide by measuring it. And this is how the thing's working. And the other thing is the overall execution speed. But when it comes to execution, which is the JavaScript execution, we have to look at the big picture first, because it's not the JavaScript that should be optimized per se. It's the interaction of JavaScript with the rendering layer. So it's most of the time is not the problem is not with the kind of loop or with the kind of tree balancing algorithm that you have written. The problem is the device is trying to render a big chunk of DOM that it should not, or there is some kind of layout thrashing that is preventing the application be snappier, or there is some kind of CSS issue or some kind of parsing issue that's going behind. So it's the intersection point of the JavaScript land with the user agent land or the browser land. So no matter how meticulously optimized your your tree balancing algorithm or your search algorithm, chances are that it won't affect too much in the performance of your overall JavaScript execution. But as always, it also has to be measured to be decided for sure. And the other thing is the concept of entropy. This flame chart is taken from a real-life application that we were developing, and we were able to reduce what you see in here to half by doing tricks like delegating complex computation stuff to web workers and reducing number of event handlers and joining stuff and getting rid of a bunch of objects. But my point is again not that. My point is your code also degrades eventually, and the more time frames you have, your code will expand to fill those time frames available. And also entropy is a fact in the code as well. As time passes by, your code becomes more random, more repetitive, more redundant, and less useful. Therefore, you have to keep an eye on the code always to make sure that everything is shipshape. And the only way to ensure it is to measure it or to track it or to profile it. And there is the other side of the coin. The JavaScript engines are getting better. For instance, Chrome's shadow and gradient rendering performance is getting better. JavaScript engines are getting clever in figuring out which parts of the code are hot, and they are trying to optimize the execution of those code. The engines are using background classes, like special classes, and using precompiled JavaScript execution to make things faster. And there are a bunch of corollaries to that. corollary one is you cannot know how fast the JavaScript piece of JavaScript code when you take it out of the context of it, because the performance of the code will depend on where you put the code. If it's in an isolated test case, it can behave differently. If it's in a production application, it can behave differently. And the other thing is, that's the second corollary, the faster all these optimization becomes, the more things we push in the device to make it, more elegant, more shiny, more dandy, and it's kind of a vicious cycle. So you have to know your frame budget, and you have to prepare for your application's optimization, basically. And there are really great articles for V8 engine on the developers.google.com website. I haven't checked Mozilla and other open source projects yet, but I'm sure they have also kind of articles too. If you're into that, this is kind of a deeper part of the equation, but if you are into that, I suggest you go there and see what's going on in the background, especially the hidden classes that the rendering that the JavaScript engine uses is a really neat approach that the engine takes to optimize stuff. And the funnest part, one of the more funnest part is frameworks, and I have a love and hate relationship with using frameworks, because especially in mobile, you have too limited resources that sometimes make using the frameworks kind of counterproductive. And frameworks are expensive because frameworks have economies of scale. To utilize the framework or to make the use of your framework, you have to utilize all the functions that the framework provides. And in mobile, most of the time, you don't use the entire framework. You use only a subset of it. And also, frameworks increase your dependency, and also frameworks kind of, let me think. They can make your application slower because they increase the memory consumption and memory footprint as well. So I'm not saying don't use frameworks, because there are good places that you can utilize them. But the thing is, at least try to minimize the framework code you use. Try to detect the parts that you don't use and chop them off and make a minified version of your framework. And also, I have an example to show the overall impact of the framework code on your mobile application. This is just a typical setup. There is nothing fancy. It's basically a backbone jQuery mobile _ setup. One thing that I did is to add a counter to each and every single function that was inside the framework code. And here are the results. So when I add a bunch of framework code back to back, I come up with this kind of a result. So this is just to warm things up, and nothing is rendered on the page yet. There are no jQuery widgets rendered. There are no backbone views created. It's just a warm-up code, and I can see 6,827 function calls just to initiate a single plain boilerplate code. And this is not the end of the story as well, because you also have to add your business logic layer, data access layer, caching layer, and all the helper plugins that you have to attach to your Shiny Dandy framework. And then after we add these all together, it kind of becomes like this. So I don't know, frameworks are kind of like burritos. They are delish, but they are hard to consume. So you have to think twice before using a framework. And also, since we are in a mobile environment, most of the things that we use in frameworks are supported by their modern API counterparts. So instead of using an ID selector, you can use document get element by ID, or you can use query selectors. You can add event listener instead of binding a link listener, kind of. So you have to think about whether to use a framework or not. And this other thing is to optimize is memory leaks. And memory leaks are not magic. It's basically, as in every language, it's just counting references from the root object to a chunk of objects. And even if there is a single reference to that blob of objects, the object cluster will remain in the memory, and it will be seen as a memory leak. And there are a bunch of suspects that causes memory leaks. One of them is event handlers or an event-based architecture. So if you are using a publisher-subscriber pattern, or if you are using an observer pattern, chances are that your memory may leak if you don't detach your subscriptions. And the other is timers. Most of the time you find forgetting dangling timer references that can leak memory. And also cache objects that are not being evicted can cause memory leaks. And there are some not so usual suspects of memory leaks as well. One of them is closures, because closures are a controlled chunk of memory, and you might have a cache object inside the closure that's growing in size and you're not aware of it. And any ER objects like manager, renderer, controller, provider can be a candidate for a memory leak. And any object that touches DOM can leak, and any object that acts like a cache may leak. And profiling memory is really hard because you have to do a bunch of heap snapshots, and then you have to take diffs of those heap snapshots. And I'd prefer a root canal instead of heap profiling every single given moment in time. And so the usual thing is to create a code that doesn't leak in the first place instead of trying to figure out what part of your code causes leaks, which is hard to say. You should not create leaks, but how? And in the case that you find out leaks, the technique called 3 snapshots technique is really helpful. The technique is kind of you do an action, you take a heap snapshot, you reverse the action, you take another heap snapshot, and then you kind of compare those snapshots, and it gives an indicator of what parts of your code is leaking. It's not still the best way or the fastest way to figure out leaks, but it eases out your pain at least. And the other thing is reducing DOM access. Since I'm lacking out of time, I'm skipping it. The less you touch the DOM, the better, the faster. And one way to touch the DOM less is to, or use less JavaScript, is to delegate your heavy computational operations to web workers. And web workers are supported in most of the mobile platforms, so you can yield your conceptually heavy operations to them with one caveat, because web workers are not free. They consume CPU and they consume processing power. Therefore, they will drain your battery. So there's kind of a trade-off, and you have to decide what to offload to the web workers and what not, which takes us to the subject of being lean. And by being lean, I mean being lean in whatever you do, like reduce your CSS, reduce your JavaScript, reduce your radio communication as fast as you can, to do as little as possible. And this article, this a list apart article, is a really nice article that sums it up. And the other thing is the overall user perception. So if you cannot make something faster, you can always make it to appear to have been faster. And there are ways of doing it. One of them is overestimating the remaining time. So if it says, if your application says it has 15 seconds to download, and the app downloads in 5 seconds, the user feel like, yeah, it's really fast. But if it says, it has a longer time to download, but it's downloads even longer, then user will feel like it's kind of really slow. And also feedback that starts earlier feels sooner. And one thing that's not in the slides is I am kind of against the progress indicators. Instead of putting a progress indicator, the UI should feel like gradually evolving. So like instead of putting a loading indicator there, you can first create a frame or like an initial frame of application, then gradually put an image, some descriptive text. As the data comes, the UI should progress gradually so that the user feels something is flowing instead of looking at blank spinner and doesn't know when the hell the spinner will go up. And simplicity is generally a way to go, because simpler code consumes less memory, is generally faster, and creates less problems. So when you are trying to put something to the code or remove something from your code base, general choice is to remove it and to go with simpler solutions. And again, a pointer to the entropy. Your application's performance will not stay the same, and if you don't put effort on it, your application's performance will always degrade. And as in nature, in code also, entropy always wins. unless you put additional effort to it. Therefore, try to, I don't know, if you're a Scrum user, keep the performance as a topic of your daily, of your weekly sprints or bi-weekly sprints, and keep performance as a goal, as a task to achieve instead of something that should or should not be done. And that's, I think, most of the things that I'd like to talk about. And one other thing is, I'm not the only one that comes up with those kind of ideas. Actually, what I talk in here is kind of a combined wisdom of a community of geeks that are bigger than me. And I'd like to suggest, if you are not following them already, follow these guys. And this is not a comprehensive list, and you can find more people to follow. Always keep in contact. Always try to learn new things, because every couple of years, some new stuff is coming and making some of the suggestions outdated. That's why I try to emphasize measuring and benchmarking always, because you don't know if you have a performance issue or not if you don't measure it. Having said that, I'm kind of out of my time, so if you have questions, I can answer them offline, and that's end of my talk. Thank you for joining me.